Right, recording is on. So last week we were talking about the data loader, exploring the data, understanding the format that we're given, and all of that stuff. And just figuring out what's in this file, how do we open this file, how do we put it in a format that's useful for training, what do our labels look like, and stuff like that. And so in this chapter, we're trying to build on top of that and say, how do we build a model that corresponds with that data, and how do we build a training loop that corresponds with that project. And so they showed, basically we've used the same training loop the past few chapters, and so we're just adding an additional layer on top of that. And they made a checklist that was basically just a series of the things that they want us to do, and that goes from this set is just their list directly out of the book. And so the idea that they wanted to show us is we need to initialize our model and the data loading. And so they've got that init that tells us all kinds of different stuff about the state of the model, how we want the data loaded in, and stuff like that. And then we also want to loop over the data in flexible ways, and we want to do it a certain number of epochs, so we can put into our function and say we want to train 100 epochs, and then it will go and do that. We're iterating over the Luna data set that we prepared in the previous one. We're using the data loader directly from PyTorch that will wrap that data set we made, and we'll make it multi-threaded and make it load in faster and prepare batches and do all kinds of stuff like that for us. And then we want to take that batch, we want to pass it to our classification model, we want it to make predictions, and then we want to measure our loss, which is just saying we've got these predictions, how far away is it from the truth, and we want to then push our model towards the correct answer in the long run. And then on top of that, we want to record the metrics over time. So how is our training loss improving? How is our validation loss improving? Is our accuracy going up? Is our F1 score going up? How are various different things interacting? Should we train it more? Are we done training? Is it not yielding any benefit? All kinds of stuff like that. And then after that, we want to check out our validation data so we can see how our training is improving, but we also want to see how does it work on unseen data. And so down the road, we might want to look at the macro level, so just what is the average loss, but we also might want to look at individual samples. So we could look at just the positives or just the negatives and look at that and see how does our metric perform on that specific subset, or we might want to like physically look at it and see why does this one get it so wrong. And so we can record all kinds of information in that regard, and then analyze it later and make decisions of how we want to change our model, how we want to change our data, if there's anything else we want to change in that workflow. And so one of the principles they laid out was we want to balance between too much structure and too little structure. So if you have some little experiment and it's a fairly simple problem and you only want to work on it once, then you probably don't want to put in all of the overhead of configuring something too complicated. But if you're doing a long-term project and you want to probably invest more time, make sure the code's properly written, everything's built into functions, and you know how everything is going to fit together, and plan out for all of your different scenarios that you might run into. But again, if it's just a simple problem that you're just trying to do a quick experiment on, then you probably don't want to waste time doing that.
So Ryan,
yeah.
If I could just share along those lines, in part one of the book, we had very little structure. And so like the entire code for our simple little problems, classifying birds versus airplanes or whatever, the whole thing was maybe 20, 25 lines of code, data loader and training loop and model or something like that. And so we took a major step up in structure here in chapter 11.
Yeah. Any questions on this section? This is kind of just laying the groundwork of what we're going to cover in the other sections. So moving on to the second section, what they explained is we're setting up a simple command line program. In the past, all of the stuff we've been doing has been inside of Jupyter Notebooks, and then turning this into a script that you can run and pass various different arguments. You can parameterize and fiddle with some various different settings. So you can type in and you can say, I want to train this for 100 epochs. I want to train this with this model or that model. I want it to train on this subset of the data. It can get as complex as you want. And the way they showed it is using argparse, where you can basically say Python, the name of your program, and then the arguments that you want to add in. And there's various different ways that you can do that. So the way they showed is just with the simple arguments, but a lot of people, what they do will configure their own like configuration file, and then you can actually just have a direct file that has all of those settings, so you don't have to put it in a command that you enter every single time. But lots of different ways to do everything. It just depends on how much complexity you want to put in and what you're comfortable with. Ted, earlier you asked me a question about the difference between like the Python and the Python-M. I was reading this thread here. I don't know if you were looking at the same thing. It's a little bit unclear exactly what the benefit is of adding this -m flag. I don't know if anyone else has additional Python background understanding of what exactly the -m does differently than just the default run.
Well, you can use it to run other modules. Like you routinely use it for Python-M JSON.tool to unpack JSON stuff. Is that just a quick one-liner? And that's not in the current directory, so it'll search the module path, I think.
Mm-hmm. It's kind of a shortcut to, like, every module has like all of the libraries and values that it supplies. And then there's that, usually that one function that it does. And people are like, hey, it'd be really convenient if there was an easy way to execute this. And so what they do is they kind of pack it into the module as the -m, it's the function that gets invoked if you're not invoking anything from the module. And so like pip is kind of a wrapper around this in a lot, where you can actually do a Python-M pip, and it's like, oh, okay, you mean you want to do a command line version of this, right? So it's just a convention from the standpoint of saying this module has all this great power, but people are going to use a lot of it in this one way, so we're going to make that command line accessible.
Okay.
So in this case, is there potentially multiple main functions, and the -m and module name tells Python which particular main to run? Is that what's happening?
I mean, to that point, it's basically saying that run the main for this module. Yes.
And if we didn't say -m, wouldn't it run the main anyway?
I mean, if you're executing stuff within, so if you're executing stuff within the module, it'll do it, right? Like, this is kind of when you're developing the module, you'll be like, oh, I can just cheat and just call Python main, right? But if I'm not developing the module and I'm just going to use it, like Tom was saying earlier, like, it's a way of getting one that's referenced outside of there. So to your point, yes, there are mains defined everywhere, but the only one that gets executed is the one that you either invoke directly or gets invoked through this module -m mechanism.
Okay, cool. Thanks.
I think I'd have to play with that a little bit to fully understand what that's doing. I skimmed through that description before the call because Ted asked me that, and I haven't honestly used a ton in terms of Python command stuff. I mostly just run a Jupyter notebook and then just get coding, and I don't do a ton of that sort of lower level building stuff. But that's just the way that I prefer experimenting with most of my simple stuff.
Okay, well, I think I get it, because there was a prep cache that needed to be run. And so what I'm sort of piecing together in hindsight is prep cache, that's prep cache.py file has a main, and training has a main. And so when I said Python -m prep cache, then it ran the prep cache stuff. But when I ran Python-m training, then it did the training loop. But both of those share like the util module and other stuff. So they're not, separate self-contained things, but the -m told Python sort of where to start execution, I guess.
And when you ran the training process, since the prep cache main was not called, it just imports the function, but it doesn't actually run the main, right?
That's right. And it may have even used some of the other functions defined in prep cache, but it never ran the main that was there. So the -m told it which one was the main that I was most interested in, so to speak.
So moving on to 11.3, pre-training setup and initialization. This is kind of going over the first step that they were talking about in this list. So initialize the model and data loading. So what they're really doing is they're just setting up all of the scaffolding, the class for the model, and all of the stuff that needs to be captured inside of it. And so they did a few things, basically saying, if we have a GPU, push it to GPU. If we have multiple GPUs, push it to multiple GPUs, capture the optimizer, and various other things inside of there. And this is kind of just laying out the groundwork, so we have this stuff available for when we want to actually do the training. And they piece it all together in one class, so all of it's captured as a single object. And then they showed designing a simple neural network. So we know that we have this 3D data, the CT scans. It's grayscale, but it's got height, width, and depth as well. And so they want to be doing 3D convolutions. And so we've learned about convolutions and max pooling and batch norm now. And so they said, we know that these are successful for this use case. Let's just do a combination of those. And what they did is they created a block they were calling Luna block. And what this really is a neural network module that includes a few different layers of 3D convolution and max pooling and batch norm. And so they can just call that Luna block in various different ways. So they can say, I want one Luna block that starts with 3 channels and has 16 output channels and has this many convolutional layers, and then it will just output a block for you, including all of those layers. So you don't have to manually sit there and go, okay, convolution, max pooling, convolution, max pooling, convolution, max pooling, and just write all of the code out over and over again. And you can add additional blocks, you can remove blocks, and it makes it much easier for you to change things. Or if you want to change the Luna block and do something different inside of it, then it makes it more easy for you to customize it.
Hey, Ryan.
Yeah.
So just one quick comment here. Again, contrasting PyTorch with TensorFlow. Keras, TensorFlow. So in Keras, you usually don't need to do that much math on like the shape, the size of the inputs and the outputs for each layer. You do at the very, very beginning, but then it just sort of automatically flows. And so in Keras, you can do the same thing where you define a block that's sort of a subclass of the layer class. and then you can reuse that. And when you do 4 of them in a row, Keras kind of does the math for you. But what you'll notice is in the PyTorch version, now we have to have an input. If you look where it says def init, it says like conv channels equals 8, because in PyTorch we have to do more of the bookkeeping ourselves to say explicitly what is the shape of our input. So that's the one key difference that I saw between defining a block in Keras versus defining a block in PyTorch. Keras, you wouldn't have those numbers that you just pass in. You would just simply say, do this, and based on the shape of the previous, it would automatically connect everything for you.
Yeah. So here's the code for the Luna block. I'll go into more detail. I have all the code pulled up in Visual Studio Code for us to look at the end, but I just wanted to pull this up as we're going. So this is what it looks like. It's an n.module, and then it's got the 3D convolutions, ReLU, 3D convolution, ReLU, max pooling. And so if you ever wanted to say, I want to change this kernel size to 5, you can easily change that to 5, and it will just change it everywhere in the network that you use this Luna block, so you don't have to go through and manually be redefining this conv 3D in 18 different places if you have a deep network.
Is it an easy way to, sorry, interrupt, is it an easy way to change, for example, the activation function, like the ReLU versus something else? Or
Yeah. So right now they have it defined here, the ReLU. They could easily change it for nn dot whatever activation function you want and just plug something else in there.
does it give you like metrics, which is like, for example, like is it a grid search or a randomized CV situation where?
Well, this is just defining the layers. It's not necessarily doing any search for an optimal network. So you could configure something that does a search for the different layers that are applicable and plug them in and alter them and stuff like that. But at this point, our setup is so simple that you would just have to do it by hand. So if you have ReLU and you want to try something else, you would have to go in and actually plug in something else in the code. But if you wanted to, you could set up something more complicated and say, okay, let's try ReLU, let's try leaky ReLU, let's try sigmoid, let's try plugging in other things in there. But it's not done automatically. You have to do something on your own for that.
Yeah, and I don't think PyTorch yet has a module for hyperparameter search or like cross-validation or anything like that. Has anybody seen that?
Not necessarily. I think they assume that you're going to do that on your own in some form. There might be something for PyTorch, but I'm not sure. I haven't used anything.
They use the learning rate. I could be wrong, but depends on the learning, like the gradient descent at what level it stopped. You do like cycles of training, and it's a weird thing, and you keep adjusting until you get the right amount. So I, like you said, I don't think there is a randomized search CV or anything like that.
Yeah. I think if you want to train it like 50 times using different parameters, there's stuff that people have done, but I don't think there's anything that's built into PyTorch where you would say like PyTorch, dot grid search or something like that. I don't think that's built in yet.
So one of the things they mention is you need to initialize your weights correctly. For the most part, PyTorch has good defaults. If it's a convolution, it'll initialize it in a reasonable way. If it's whatever other layer, it'll do a decent job. But if you ever want to do something more custom, they showed that there's pretty easy way within the nn.init. You can do various different methods, and it will automatically initialize them for you. I've hardly ever touched this. I don't think I've even looked at it. I've seen some research code where they mess around with this stuff. I've never really messed around with it because the PyTorch defaults are pretty good.
So I must have missed that, Ryan. So if you don't create your own initialization, it won't do zeros. It has some default initialization for each kind of built-in layer.
Yeah.
Okay.
I don't know what the defaults are for most layers, but I know that it's not just doing zeros, because if it was just zeros, then it wouldn't typically converge.
Yeah, because like Keras, I don't typically do that either.
Mm-hmm.
I just let it initialize with whatever the default is.
Yeah. And then moving on to 11.5, training and validating the model. We've seen the same setup multiple times now, so I'll just highlight the things that are actually of significance. So the one thing they added in was the enumerate with estimate function. And what this does is it shows as it's making progress through the epoch, and then it also tries to make an estimate of the completion time. So you can get a feel for, is this going to take 3 minutes or 3 hours or 3 days? And that's pretty important, because it can be a good red flag for maybe I'm doing something wrong if it's taking way too long and it's not that much data, or maybe my model's not even being trained and it's getting finished in 3 seconds, and that doesn't make sense for your use case and stuff like that. And it's also good to just see the progress as it goes along and know, okay, I can go have dinner and come back and I'll see when it's finished. And so I don't typically use something as complicated as what they have set up. I typically just use the TQDM module or Python package, if anyone's familiar with that. And all that does is it just shows a loading bar, and it knows your total amount of batches, and it knows as you're iterating through that what batch you're on. And then it also shows you the elapsed time and the total expected time potentially, but it's a fairly rudimentary extrapolation. Typically, I just look at it and I see, okay, it's done 100 batches in 3 seconds. That means that if I have to do 200,000, then I typically extrapolate on my own, because its own estimates are kind of greedy in terms of the most recent batch that it's looked at. But this is a useful function. I would say mine typically isn't that complicated, but now that you have this, you can just plug it in most of your setups. And then the other one they had is a function to compute the batch loss. And so one of the things in the loss functions from PyTorch is they automatically do a reduction of some sort. So if you have a batch of 16 samples, it will take the mean and it will say, okay, the mean across this entire batch, the loss was 0.2 or something like that. And that's good for the sake of computation and just getting a good summary of things, but it's not good if you're trying to look at individual samples. So if you're looking at it and you're saying, okay, why did this batch show up as a loss of 25 when everything else was at 0.2? You would have to look across the entire batch of 16 and then say which of these was high, and you'd have to kind of figure that out yourself. And so if you turn off that reduction and you say, just give me the individual loss for every single sample, then you can just directly map and you can say, oh, wow, this one showed up as 100 and everything else was 0.2. And you can look at that example and you can see, oh, well, somehow this is a picture of a dog. It's not a CT scan. So that's why our loss is so high or something like that. And so this function is pretty useful because it just basically says, return the individual losses, but also compute the mean. So you can also see at the batch level, and you're also keeping track at the individual level, just keeping record of that and understanding which ones are high, which ones are low, and at the specific sample level, so you can pinpoint what's going right and what's going wrong. And so they have two different setups, one for training and one for validation. This is good because sometimes you don't necessarily want your loops being exactly the same. Sometimes you might not care about certain metrics on training, and then you want to see more deeply what's happening on validation, or you want to do something else special on validation. You want to just log an additional file or do something else. And so having some overlap of these is expected because you're still iterating through data and you're still making predictions with the model and stuff like that. But you typically want them to be at least a little bit divergent. So you typically want two separate versions of these. Any questions up to that point? So moving on to 11.6, outputting performance metrics. So given that we have the loss of the individual samples, we can keep track of all of that stuff. We can write it to a file. And then we can also keep track of the confusion matrices and other metrics that we're interested in. It just depends on your problem. In this one, we're doing binary classification, so a confusion matrix is a good way of looking at it. Later in the chapter, they showed that looking at the confusion matrix, you can see that something we probably don't want is happening. And so they basically showed in their code, here's a way to just continuously write what's going on and keep track of the metrics that they're interested in. And then moving on to 11.7, running the training script, they showed the example of them running it from the command line. And then once you run it, you want to see, is everything running properly? How well is my CPU being utilized? How well is my GPU being utilized? And you can look at your CPU usage using top, and you can look at your GPU usage using NVIDIA SMI. And so what both of those will show is basically, if you've got your code configured to be using 16 threads or processes or whatever it might be set up to be, you want to see that it's actually using all of your resources. And then if you do NVIDIA SMI, you can see your memory utilization and your wattage and your fan percent and all kinds of stuff like that. So you want to look at it and see that your GPU is actually being hit. You're utilizing the memory that you have, that your GPU isn't sitting idle waiting for your CPU or something like that. So there's not necessarily surefire ways to diagnose that, but you can at least look at it and you can see, okay, my GPU is just sitting at 7%. Maybe it's a bottleneck in my data loading. Maybe I'm doing something else wrong that's just causing too much IO. And so you can look at that and dig a little bit deeper. If you see utilization isn't what you expect it to be.
Hey, Ryan, just a little bit of trivia. When I've been training stuff in Keras and TensorFlow, I know I'm running on Windows and Windows is evil, but like Windows will typically say my GPU utilization is like 16% or something like that. And when I run NVIDIA SMI, it'll be whatever, 92, 98, whatever. But PyTorch is doing something different because when I ran this training, Windows said my GPU utilization was 0, even though when I ran NVIDIA SMI, it was 99%. So somehow it's using slightly different CUDA subroutines because Windows basically didn't see it at all.
So if I'm remembering this correctly from when I used to work on Windows, if you go to that screen again, there is a drop down that will tell you various different things. And so one of them is 3D, one of them is compute, one of them is 2D. There's several different categories. And you have to hit the drop down and you have to pick the one that says compute. And it should show up under that section.
I'll try looking at it again. I mean, I definitely have some of those categories. And I know it's not doing video decompression, it's not doing 3D, but yeah, for whatever reason, it was seeing the compute under Keras, but it just wasn't seeing it at all under TensorFlow.
Huh.
I don't know, random fact.
So in the next section, they're looking at evaluating the model. So like I was talking about before, the metrics, they were showing, hey, look, we've got 99.97% accuracy, but then if you actually look at the confusion matrix, you can see, okay, it did that by just guessing that nothing is a nodule, and that's not very useful for us. So actually keeping track of the things that are relevant to you is really important. And so looking at that confusion matrix, you get a little bit better insight into, okay, our model's actually not doing very good. We can't just summarize it with accuracy. We need to do something else to convince it that it needs to be doing something else. And so in the next section, they were talking about graphing the training metrics with Tensorboard. This is something that I've always avoided because it kind of just seems like unnecessary overhead to me, but it gets shown in pretty much every book. So if you write your metrics and various different things to the logs, then you can, in the right format, then you can load it up in Tensorboard, which is actually originally a TensorFlow tool, but you can output stuff in the right format in PyTorch too, and then Tensorboard will just pick it up and be none the wiser. And then within Tensorboard, you can look at various different things. So you can look across different models and different training schedules, and you can see the learning rate over time. You can really make it show any different metrics and things that you want to log. It really is kind of agnostic. You can plug pretty much anything in there. You just need to put it in the right format, and it will graph and do various visualizations for you. I haven't really bothered to set it up. I know that some people like it, but for me, it hasn't been particularly useful. If I want some visualization, then I just plug it into Matplotlib. I don't need a live dashboard to show me as it's going. But just so everyone knows, it's available. They're showing that in the torch.utils.tensorboard, they've got various different tools there for allowing you to write the logs in the correct format for it to be picked up. And then in the final section, they had discussion about why isn't the model detecting the nodules? Why is it just always saying no nodule? And so part of that is the large class imbalance. So the majority of the cases are going to show up as not having nodules. And then the other thing is having objectives that don't really penalize properly for what we're interested in. So there needs to be some weighting. Otherwise, it's much easier to just guess always no nodule than it is to guess nodule once or a few times and get heavily penalized for that. It's just significantly harder trajectory to learn when you've got so few examples of the nodule class. Any questions up to that point?
No, but I have a comment, and that is I feel a little bit like I got sucker punched on this chapter because we did all of this work just for them to make the point of the class imbalance, right? Sort of thing. So I feel a little bit cheated. That's all.
Because you thought it was going to work better, or?
Yeah, because I thought it was going to work better. But I mean, we did all this work, and the point was, it looks like it's working, but unless you look at the confusion matrix, then you don't realize that it's not really working, which, okay, it's a good lesson, but I feel like we did a lot of work for that lesson.
I think they're partially trying to drive home the point that it's important to look at it a bit more holistically. rather than just looking at loss or something like that. And then I think the other part they're trying to show is if something goes wrong, how do you fix it? So if you're not getting the results you want, how do you make adjustments and then improve it down the road?
Yeah, I agree. I mean, they're both valuable lessons. Yeah.
Yeah. Any other questions? So in this chapter, we don't have an individual notebook. We have a whole bunch of files that they've configured, and this is going along with the structure that they were laying out and building upon. So I typically don't work like this. I have for certain things for work, but for the most part, when I'm working on Kaggle competitions and building out my models, I don't typically experiment like this because I feel like it's typically too much structure and not enough flexibility when I want to go, let's just change some small thing, or this isn't working now, I need to figure something out. But we can run through these files and just kind of understand roughly what's going on. There's quite a bit in here that they haven't really explained though, so I wouldn't worry too much about this data set stuff. This is kind of inheriting from the previous chapter. They've basically set up a data prep step that's doing a whole bunch of stuff under the hood, like pulling in the cache if you ran that prep cache step. And then preparing the data in various different ways. I don't really have a great explanation of most of these, but eventually it builds up to that Luna data set that we discussed last week, where they're preparing the data for the actual consumption from the model, and it ends up manifesting in these 4 points that we discussed last week.
Is there anywhere we could go into more details into how they prep that data to get it into that format?
Well, that was the detail of last chapter that we were looking at. So if you want the in-depth look, then you have to look back at the last chapter, and they explained, okay, we did this to load in all of the MHD files, and then we split off the ending of it, and then but I think it would be a bit cumbersome to go through the whole thing line by line.
So Ryan, I don't know if maybe there's a like a blog post or something about PyTorch dataset loaders that might be a good topic down the road. I didn't go through the code too closely from last week either, to be honest. But the big picture concept, right, is that you've got stuff running on your CPU in parallel that is pulling the files from disk cache, whatever, doing whatever prep. In this case, we're not doing a lot of prep. We're not doing augmentations or other things. But if there were transforms necessary, it's doing that. And it's doing all this on CPU in separate threads in parallel, while the main model is doing all the heavy number crunching, matrix multiplies, convolutions, whatever, for your deep neural network on the GPU. That's the typical. And so because you have the two processors on your computer, you can actually afford to do a decent amount of work on your CPU to prep and pipeline the data. And ultimately then it has to do that copy. So at the end of it, it's basically going to move the tensor to the GPU. And then the GPU picks it up as the inputs in the neural network. So I don't know if that helps.
So part of this, why I'm kind of skimming over some of it, is a lot of this is just very specific to this project. So in this, they have this SITK, which is simple ITK, which is not a package I imagine using very often. It's just very specific to this format. And the rest of this is all just very specific to the data. So if you're trying to build a data loader for your specific project, you're going to have to know, okay, I have it in JPEG format, so I can open it in OpenCV, or you can Google it and you can see the various different ways that you can open a JPEG and stuff like that. But learning this is not really going to help you in future projects unless you specifically are solving for this file format and you have labels in this format, and you're trying to piece everything together. So the data munging step is fairly difficult and cumbersome for most projects, but it's something that kind of has to be custom for everyone because data always comes in different formats.
In production, do they break a long script into few smaller ones? Does it make sense then? Like you can delegate working on one small script to somebody and it would be easier to check out.
Yeah, I think that's a good point. So like, I think one example of where they kind of did that is with this prep cache thing. Someone could specifically write this and then everyone just uses it. And you just need to know, here are the inputs that are going in and here are the outputs that are coming out, and then everyone else can build around that. I think that process is kind of hard though, at least when I've been collaborating with other people, because fairly often, if you're wanting to try something new, it breaks a lot of things down the line. So one example of that is, let's say that we'll be doing this in a later chapter, but just imagine a scenario where instead of just classifying nodule, not nodule, we want to directly make a mask of where we think the nodule is. Now we need a different format label, we need a different format model, we need a different, and all of these things need to piece together. Now our metrics don't make sense anymore. So at least in my experience, it's fairly difficult to change just one piece, kind of naive to all of the rest of the pieces. But there's definitely opportunity for that, but it's a little bit tricky, is what I would say.
So I guess what would be the other way that you do this then? You just have it in the notebook, defining a class. Is that what you mean?
Well, it depends on how many people you're interacting with and what exactly you're trying to do. So on my projects, I typically only have one or a few people working on something. So it's okay to work as a notebook and then just basically pass around the notebook and say, hey, I made these changes. Now we have to do things like this. But if you're working in a big team, then you probably do have to do something more like this, where you're saying, I'm very rigidly defining what all of these functions do, and we can't deviate from that because it's going to break everything else. That's part of, at work, one of the things that I've been running into is a lot of our interfaces rely on the format from sklearn. And so a lot of the times we'll go, we'll go, hey, wouldn't it be nice if we could solve this new problem? And then we kind of just have to backpedal and say, well, maybe that's not possible within the sklearn API setup. So there's just trade-offs. There's a certain point where it becomes more maintainable if you limit the scope of something, but at the same time it becomes less flexible and you can't quite do as much. And so on my projects, at least, I've favored flexibility where we just have everything built into one notebook, and if we're making changes, the entire thing is one package.
So the notebook would contain a data loading section, right?
Mm-hmm.
And the transformation. But I guess what I'm trying to get at though is how would that be different though? So you wouldn't make it a class, you just leave it as a function? Because is that what you're talking about?
I'm not necessarily saying anything needs to change here. I'm just saying that there's different ways to do it. So in this case, they've split everything into different files, and then they run it all as a command line thing. And I'm just saying that doing it this way, you can't necessarily say, okay, you just work on the data set, and you just work on the model, and you just work on the pre-cache. Maybe the pre-cache, but I'm not sure. But typically, even when you split things into files, it still doesn't necessarily guarantee that you can be flexible. I don't have any, like, I'm not trying to make any statement here. I'm just saying there's different ways to organize it depending on the complexity of your project and how many people you're working with.
Oh yeah, sure, that makes sense. I was just curious, like the other, like, yeah, what else is done? I mean, so for me, it's typically, I mean, I work basically by myself though, but I still, to reduce the amount of scrolling I have to do in my notebook, if I have a function that works pretty well, then I'll add it to a script and then load that script into the notebook when I execute. So it's just more of a curiosity for me of what others do.
Yeah. That's the same as what I've done in the past. Is I've got a notebook and then I say, okay, I've been using the same data loader. I'm never changing it. I'll just move it to a utility and just import it rather than having it directly in the code. Yeah, that's similar to what I've done in the past.
Well, thank you.
I find it interesting from the standpoint of, like, we have similar discussions at work from the standpoint of, like, oh, should this be in code such that it can be put into version control systems and followed up that way, versus, hey, a lot of the data scientists and ML engineers really just want to work out of the notebooks, and trying to marry the two together. It just, like, I don't think there's a clear answer industry wide. This doesn't feel like it. I was really hoping to hear something here, but I guess not.
I feel like from what I've seen, it depends if you have like a DevOps team or not. Like if you have a DevOps team, they always like want you to be splitting things up for like testing purposes. But like if you're in a data science environment, notebooks are the go, especially for testing and research.
Yeah, I mean, a lot of things will depend on the environment around it. And so, like, we have a lot of online services. So we have a lot of stuff where it's like, oh, we should treat everything, like even our deployment and our development practices, such that they mirror that. And it's like, does that really make sense? I don't know. But it definitely causes a little bit of back and forth.
So going off on a bit of a tangent here, but like Jupyter has a function where you can save your notebook off just as a Python script. And so I've wondered if anybody's looked into just sort of automating, push it to a Python script and then push it into version control so that, you have nice, clean, like code diffs, right? So but just let the user keep working in the Jupyter environment.
There are and it very much to the previous point, depends on, what pipeline has been set up there. Because there are definitely tools that will clear it out, clear out any of the markup, not just pull the cells, but pull everything, right? And then there's even ones that actually use some of the metadata and allow metadata markup. There's something called Kale, K-A-L-E, where basically you can start annotating your cells with like, oh, this is an experimentation cell. Don't actually include it. It's like, oh, this should be a package cell. And like, it will go through and it will try to reconstruct part of that. So yeah, Interact does a lot of the cleanup work, but, and like NB clean, I think, I forget. But there's a bunch of stuff out there. So I feel like it's all over the board. There's not one clear answer.
So with that setup of having a Jupyter notebook, which then you export to Python scripts and there's some cleanup done, is there, I guess, a way to, in each cell, to say like, hey, I actually want this to be part of a separate script? Because I could see a problem being like, you know, lines of code wise, it could be 1,000 lines of code if you just export everything inside the Jupyter notebook. So I'm curious about that. Does Kel do that, or Interact, or those other ones that you had mentioned?
Kel does it with does it to a small degree. It's not as robust as what you're talking about. It mainly is kind of pruning out experimentation cells rather than packaging cells. But it does have a few different tags you can put on the cell, and I'll apologize. I don't remember the exact ones. But yeah. So the other ones I'm not as familiar with.
That sounds interesting to me. I have a Jupyter notebook that I run at work, and it has a sequence of steps that it runs. But I do have a couple extra cells where I'll just say, show me the head of this data frame, or count the number of unique employee IDs, because I want to make sure that the number of rows equals the number of unique employee IDs, things like that, right? And so actually, if I could just label those as like, those are just experimental or whatever, you know, eye candy for me as I'm running just to see what it looks like. They're not really the main line of code. Then that would be kind of nice.
So there's been a lot of work that's been done from Netflix and various different organizations trying to figure out how do we actually use notebooks effectively in our data science workflow and integrate it with the various different kind of traditional software engineering, version control, CI/CD, and stuff like that. And there's interesting tools. I don't think that anything has been solved necessarily. I think it's just a little bit complicated. I think in my opinion, I almost always favor rapid prototyping over backward compatibility and proper versioning of everything. But that's just because the stuff that I work on is typically fairly short term, and I'm just trying to iterate as quickly as possible. I'm not trying to necessarily have the ultimate path. I'm not releasing package versions or doing anything like that.
Sorry, I know this is not really on a chapter. I'm just curious as well for other people. I think I've heard about this before, but has anyone run, because typically if you take your code into production, right, application, you'll be doing modules and different Python scripts. But I thought I heard somewhere that people actually can run notebooks in production. I was curious if anyone knows anything about that.
Yeah, I know there's a couple of systems that'll do scheduled notebook invocation. Yeah, I mean, you can, and some packaged products like Databricks will allow you to do a scheduled notebook execution. So it really depends on which extensions you use.
The AWS SageMaker platform allows you to develop in those notebooks, and you could execute those notebooks using a cron job, but typically they're just Dockerized. So you have methods to facilitate creating Docker images from those notebooks so that you can execute them within the AWS environment. But typically once they're put into production, it's within a Docker image.
And so the container though will contain the notebook though?
That's right.
Yes.
Okay. Interesting.
I think they even also have something that I think it's called Cloud. I'm gonna have the name something, but it's called Cloud something that does the setup for everything for you. And it's almost like how Docker works, but you don't even have to include the Docker image in it.
Well, there's
it
Cloud
uses
Formation.
EC2.
Yeah,
Yeah, exactly. Yep.
CloudFormation, but SageMaker doesn't really work with CloudFormation. The other AWS services do. They don't yet have a way to like import that CloudFormation to SageMaker. I mean, that notebook into SageMaker, but you can call the APIs for SageMaker through that.
Yeah, you're right, because mine, the last time I used it was pulling from Jupyter, with Jupyter Lab.
Right.
And it worked, yeah.
Right. So, so that's typically how you would run it in production within SageMaker, but you can do it just calling it through a cron job. Because underlying EC2 is just, I mean, underlying SageMaker is just an EC2 instance. So you can use a cron job to call those notebooks directly from the EC2 instance.
Yeah, I think there's actually a lot of different ways. I think it depends on what exactly you're trying to do. So one of the things that I've done in the past with Jupyter Notebooks is you can basically directly deploy an API using Jupyter Notebooks, which is kind of crazy to think about. So you can use the Jupyter kernel gateway, and what it essentially does is it will do like the first time setup. So you can say basically run all of these lines of code, and then it will just sit at a certain cell waiting for arguments to be passed. And then it will take your argument and run that specific cell given that argument. And so you can be in this kind of crazy scenario where you have a Jupyter notebook that's deployed as an API basically, and it'll just happily sit there and run continuously and take requests from the web if you want to. Just an additional tool I thought I'd throw out there.
That's great. Thanks, everyone.
I don't remember exactly where we left off. Looking at the Luna model, we kind of looked at this within the code a little bit. They defined this Luna block down here. So it's all the 3D convolutions, ReLU, etc. And then they just stack a bunch of those going forward. And then that's pretty much the gist of their model. There's not too much stuff going on here. It's fairly concise because they define the Luna block, and then the Luna block makes a pile of 4 or 5 layers, and then they can define 4 of these, and that replaces 20 to 30 lines of code, basically. And so the Luna model ends up turning out to only be 46 lines total, and most of them are kind of optional.
So Ryan, looking at that code, after you do your 4 blocks that each have, right, 2 convolutions and a max pool, then they have the linear layer, and I see it looks like it's hard-coded there, 1152. So this is where if you decided, oh, instead of 4 blocks, I'm going to try 5 blocks and see if my, my network learns better. And then as soon as you say train, error message.
Yeah.
Your input to the linear layer is not the shape that it was expecting.
Mm-hmm. Yeah.
So that seems to be one of the common pain points with PyTorch.
Mm-hmm. Yeah. I'm not entirely sure why they did it that way. That's kind of an oversight in my opinion, but because
I mean, in the blocks you can see they did math to figure out the input and the output size.
Mm-hmm. Yeah.
So,
but they're parameterizing this to make it seem like you have some option to change this, but if you change it, it won't work.
Yeah, that's an optimistic interface, right? Like let's put these options here, and then later we'll figure out how you can actually change them.
Yeah. But again, I just wanted to share that because I'm, you know, just starting to use PyTorch. And if other people are starting, like, you should not feel bad if you're getting these errors. This is something that seems to just, everybody runs into this.
Mm-hmm. Yeah.
Do you think that some of that, the auto magic munging of sizes that's happening in TensorFlow is allowing them to be more agile in terms of sort of the auto ML sort of architecture search stuff, or is that not really a factor?
I don't think that's a massive factor in that, because a lot of this stuff in PyTorch, if someone wanted to make some sort of auto tool, they could pretty easily just calculate things, because the formulas are known. It's just that they're not explicitly calculated in PyTorch for the sake of giving additional flexibility, because the output from this block can change dimension based on the input image size potentially. So if you have a 200 by 200 image, its output is going to be different than a 100 by 100 image. Whereas Keras would just say, we always get the same size and it has to be that.
So it's more the flexibility sort of gets moved around in the automatic munging versus the panel. Yeah.
And it could be done in PyTorch as an additional layer on top. But by default, they just give you more flexibility than they do kind of automatically defining all of those things.
Right.
Yeah, like it seems to me, and maybe this is just because I'm a lazy person, but like every now and then you're going to do some kind of complicated transformation between two layers. But for the common case where you simply connect the outputs of one layer to the inputs of the next layer, right? That there could just be this new like PyTorch.DoMyMathForMe class, right? And so then you just say, you know, conv 3D, you know, and then you pass it, do my math for me input, do my math for me output. And then the next layer says, you know, do my math for me input, do my math for me. And so then that class just keeps track of things as long as you plug them, it just, you know. So I suppose if you ever made a mistake and you like accidentally typed conv 2D instead of conv 3D, right? Then it'll just maybe do something and therefore you won't realize you had a mistake because it did the math for you. But it does seem to me like that ought to be in the next version of PyTorch, you know? Like when you're just building a simple sequential thing, just why do I have to keep typing all these numbers?
Yeah, almost like a decorator. It's just like, oh, what am I getting? Okay.
Yeah, like a decorator. I don't know Python that well, but a decorator that basically says, my input is the same shape as the previous layer's output, damn it.
Right.
So looking at this prep cache stuff, I haven't looked at this one in too much detail, but what I can pull out is it's pulling out some argument. Looks like it's batch size and number of workers, and then it's setting that to some variable. And then when it's calling the main, then it's logging and saying, I'm starting with this name and these arguments. And then it's setting up the data loader with the Luna data set, with a certain batch, with a certain number of workers. And then it is using this enumerate with estimate in order to keep track of the progress and give an estimate of when it'll finish. And I think during this data loading process, it's preparing some cache file that will just speed up the data loading in future iterations. That's my understanding of this whole file. I'd have to understand what exactly is happening in order to do that caching, but I think that that occurs in the dsets.py file. Is that, Ted, you actually ran the code, right? Did you run this prep cache?
Yeah, actually, I forgot to do the prep cache. And so I just called train, and I don't know what happened, but basically it was really, really unhappy. So it used up all the memory on my computer, and CPU went to 100%. And I don't know what it was doing, but it never got around to doing any training. It was just spinning its wheels. So maybe it's not just that the caching speeds things up, but also that somehow the code was written to expect the cache, and when it's not there, it just does something really dumb. I don't know.
Mm-hmm.
But the book actually says, like, hey, now would be a good time to run NVIDIA SMI and see if your CPU utilization is low and your GPU utilization is high. I was like, no, it's not. It says, and if your CPU is high and your GPU is low, then maybe you forgot to run prep cache.
Mm-hmm.
You know, so then I hit Control-C. I ran Python -m prep cache, and that didn't take very long. And then when I ran it again, all of a sudden it was completely different. It didn't use that much CPU memory. It used almost no CPU. It was like, I don't know, 3% CPU or something. And then my GPU was pegged at 99%.
Mm-hmm.
So I don't know. I may need to reread chapter 10 if I really want to understand what's going on. But I think we can maybe focus on the model and the training scripts.
Mm-hmm. So then here's the actual training script. They've got this Luna training app. It does the same thing. It pulls in the arguments. It can take in number of workers, batch size, number of epochs, this Tensorboard prefix, and then some form of a comment. I don't know exactly what that's for.
The comments to name your runs in Tensorboard.
Mm-hmm. Okay.
Because otherwise it just has these auto-generated date timestamp things, and once you have more than a few of them, it's completely inscrutable.
Mm-hmm. Yeah, that makes sense.
So like, for example, if you wanted to say, run with 5 Luna blocks, run with 3 Luna blocks, run with batch size equals whatever, you know, something, so that you can know what actually was different about that run.
So then they set up the train writer and val writer. I'm sure we'll see more of that later and figure out why they're setting that to none. Total training samples count. So this is probably iterating and just keeping track of how many training samples have we passed over, checking if there's a CUDA device. And then if there's a CUDA device, we'll use it. If there's not, we'll push it to CPU. And then they're initializing the model, initializing the optimizer. And then what those actually mean happens inside of here. So they're utilizing that information we just found. So do they have a GPU or not? And they're using that for the model and the initializer. And then they're starting the train data loader. So they've got that data set they created in the other file, and then they're setting the validation stride. So they talked about this in the previous chapter. Every 10th step, they're doing a, they're keeping it set aside as a validation piece. Batch size, and then they're taking the batch size, and if you have multiple devices, then they're multiplying it by a certain factor. So if you want a batch size of 32, and then you have 4 different GPUs, then they're actually doing 4 times 32 rather than just being 32 and splitting that across 4 GPUs. Then they're taking that data set they created and they're wrapping it in the data loader with the right batch size, the right number of workers, and then they're pinning it to the memory if it is a system with GPU. So I'm assuming you didn't fiddle with this, Ted, but did you try setting pin memory to false?
Trying to get off mute. No, I did not try that. I don't think it would have made a difference for this data set, right?
I'm not entirely sure. I've never seen pin memory make any big difference, but they chose to explicitly set it, so I'm assuming that in this case it probably does, but I'm not sure. I haven't seen that used very often.
I mean, basically, when I was running this, I wasn't doing anything else with the GPU, right? So there's no real competition for memory. So, so in that sense, prioritizing to keep this in memory shouldn't really make a difference if nobody else is actually asking for any GPU memory.
Yeah. Yeah, I'm not sure. I haven't seen a big impact on that in the past, but maybe.
Yeah, I mean, the only thing I can think of is if you actually had multiple tensors and certain ones you were like, you know, your data files and you're going to reuse them, and other ones for some reason were just very short term and you weren't ever going to reuse them. Like, here's a tensor I use somehow to calculate my metrics or something like that. Then in theory, you would say, well, if you need to offload something, offload this one because I know I'm not using it again. But I'd prefer you not unload this data thing or whatever. But I don't know. I mean, the data is big enough that it's not like the entire epoch is going to ever fit in my GPU memory, I don't think. So
yeah.
So it's all going to get unloaded at some point.
So then they're initializing the Tensorboard stuff. So they're basically saying, prepare the file directory stuff. So just it's going to be named runs, and then your prefix, and then your time, I guess. And then with the summary writer from the PyTorch utilities, they're going to start putting it in that log directory, one for the training and one for the validation, and then optionally with the class if you added that, or the comment. And then we add the actual meat of it, the main, and so that's going to write something to the log. It's going to initialize the training data loader, validation data loader, and then it's going to go a certain number of epochs through the data. And every time it's going to log all of this information. And then on top of that, it's going to set the training metrics. So this is going to be the operation that actually does the training. We tell it the index of the training epoch, so 0th epoch, first epoch, second epoch, and then we're passing it the train data loader, and then it's outputting the training metrics for us. And then when we want to log things, we're passing it to this function, and we're giving it the index of the epoch, and we're telling it it was training, and then the train metrics, and then we're doing the same thing for the validation. Then if we look at the training, this is kind of just the same thing that we've been looking at for the past few chapters, with this enumerate with estimate that we've talked about. And then they're also keeping a running total of the number of training samples that they've seen. So every epoch, they're iterating across 500,000 images or something like that. And so every epoch, we're adding on that number. So if we're doing some running total, then we can say, okay, our total loss is this amount, but we're going to divide it by the number of samples that we've seen and stuff like that. I typically don't log this. I typically just store things as the mean. Maybe there's some strong reason for them to do it like that. I don't entirely understand why that's a necessary variable to keep around. Maybe if you want to recompute things in the future. Validation, pretty much the same, just not actually training. Computing the batch loss, doing a whole bunch of stuff in here. This is kind of the stuff they were talking about in the book, keeping track of the various different metrics. So kind of forming it. Yeah.
Hey, Ryan, just one quick note. So if you go up a little bit to the main training loop, okay, so in past weeks, we've talked about you call the model, right? You calculate your loss, you zero your gradient, and then you call backward. And that's where the learning actually happens. You call optimizer step, which does the backward, where the actual training happens. So when you look in this loop, where is it? Oh no, sorry, do training. Sorry, go down a little bit, yeah. So you can see right above the comments, you have the backward and you have the optimizer step. But wait, where's the model being called? So in this particular case, because they did the fancy version of calculating the loss for individual and batch and all that, so then when you scroll down and you did the compute batch loss, you will see in there, where is it, line 231, that's where they actually call the model. So that's where it actually shoves the data into your neural network and computes and makes the prediction. Okay, so if you didn't have this fancy compute batch loss, you would have just seen it in the do training function. So just in case somebody's trying to read the code and they're having a little difficulty, the training loop really isn't any different. They just have a bunch of fancier bookkeeping wrapped around calling the model.
Yeah.
And you typically see the things like precision and recall being computed on the validation side. And it's compute batch loss. It's called for both, right? Do I have that right? Both for validation and for training.
So it is in training, and yeah, it is in the validation loop as well. Yeah. It's generally good to get the numbers for both just to see how things are progressing. So you can see it on the training set. Is it at least learning something? And then on the validation set, you can say, is it generalizing to unseen data?
Sure. Yeah, I was kind of curious. These metric labels, so they've got label index, pred index, and loss index.
So my reading of this is the I'd have to review this, but I think that this is the index is what they're saying here. So they're matching all of these together basically. And when they're looking at so this is from, where's this? This is just defining the columns that they're pulling the different pieces of information from. So this is just saying basically this column has our labels, this column has our predictions, this column has our loss, etc. And so down here, go ahead.
I was going to say, I don't think they're actually calculating anything here. Okay. What they're actually doing is they're just saving off for every single example. What was the prediction? What was the label? What was the loss? And then later on, you can do whatever math you want. You can compute whatever metrics you want, whether you want sensitivity, precision, whatever.
Yeah, my brain just clicked in and I see the list comprehension now. Before I just didn't see it. Like I was seeing those square brackets as parens or something. But yeah, they're taking the various columns within the structures that are returned from the running the actual model, right, on probability and logits to
Yes.
fill in these structures. So they know for every single training example that went in that batch.
So my note on this would be that our CT scans, each scan is of a fairly decent size in terms of the number of bytes in a single CT scan. But the number of examples, well, in this case, we're not even looking at the full scan, we're looking at whatever. But the number of examples we have is relatively manageable. I think, right, it was hundreds of thousands.
Mm-hmm.
So in this case, you can save off every single one of the hundreds of thousands of results individually into this thing. But if we had a different use case and we had 2 billion training examples, then you probably wouldn't want to try to do this technique where you save each and every individual example. What was the prediction? What was the actual?
Yeah, I mean, obviously this makes it easier to do sort of digging in and figuring that stuff out that Ryan was talking about earlier, where I want to see a specific example and then I find out it's a dog or whatever.
Mm-hmm. Yeah, so when your set's not that big, I actually was thinking, oh, I might just reuse this code in some project. But just a warning that if you're doing something with a lot of examples, then you may run into issues. You're just taking up too much memory, keeping track of all this junk.
Right. Following up on the question I started out with, I'm not seeing sort of a precision recall sort of metric here. There's a lot of
no
logging of the loss. Do you typically try to track that alongside the sort of just the raw mean loss? Because I mean, obviously with these imbalanced sets, right? Maybe that's the next chapter. I don't know.
So I always get tripped up on the formal names of all these things, but basically what they ended up calculating is the predictive accuracy on the positive examples and then the predictive accuracy on the negative examples. And I apologize for forgetting the exact names of those, but I think that might be what it is, right? Positive, predictive, whatever. But anyway, whatever you use, you do need to look at sensitivity and specificity. In this case, precision and recall may not be as obvious as just looking at negative accuracy. So in this case, negative case accuracy was 0. Okay, if you looked at, well, I guess it depends on which case you define as your interesting case. But so I guess in this case, precision recall would have worked. But sometimes you have to be, it's a little bit more whatever. But you can always just spit out the full confusion matrix. So they've logged enough information here where you can just see, since it's binary classification, you can just see the 4 elements of the confusion matrix. So.
All right, thanks. Yeah, and I didn't see this log metrics calculation before, so
yeah,
that makes sense.
And when you're done, Ryan, I can just briefly show like the actual metrics they spat out.
So what they're showing here is basically they're making a mask in this log metrics function. They're making a mask, so they're pulling out all of the negative labels, and so they find that by saying all of the ones below the classification threshold, and then they do all of the negative predictions, and then they're kind of just looking at where did these match, where did these differ, and in what ways, and so on. And then they're kind of just keeping track of all of these so that the combination of them and then just summing it up. And then they're logging it in all the different ways. So they're doing the loss of all of the samples, the loss of just the negatives, the loss of the positives, and then they're doing the number of correct on all of them, the number of correct out of the negative, or correct out of the positive. And this code is flexible enough that it's really just whatever metric you're interested in. They're just showing examples of it. It's not necessarily you always have to use precision and recall or whatever. It's just whatever is relevant to the problem that you're looking at. And then it looks like they're capturing some histograms of something. And then you'll probably see that the predictions are really skewed to one side and the labels are as well. That's probably what they're trying to show there. So that's the gist of the training loop. You wanted to show something, Ted?
Yeah, I was just going to show the actual Tensorboard. So we log all this stuff, and then where's my window? So then here's our Tensorboard. And I've got a 10 epoch run on here. And most of these curves don't look that interesting because it didn't really learn that much. But so if you look at the predictions, then you can see here that, you know, hey, look, 99.8%, you know, correct. And then basically it's at 100% correct as far as you can tell on the negative cases, but it's 0% correct on the positives because it just guessed. No, it's not a nodule for every single one, predicted 0. And then you can see the loss curves do actually move a little bit. So this is what you get if you integrate with Tensorboard in terms of, Ryan was saying, you could have just taken this data and you could have just called matplotlib and you would have gotten the same curve. But if you do the legwork of spitting things out into the correct format into a subdirectory, then you can just point Tensorboard at this directory. And you can do things like you can compare runs. So I don't have an interesting run. This other run was only 1 epoch. But if I turn this on, then you can see sort of, well, how does this compare to that? And so if you wanted to look at the loss curves of 2 different runs, so let's say you did 4 Luna blocks versus 5 Luna blocks, then you could overlay them on this chart. And so I haven't used Tensorboard a lot, but that's the kind of functionality that you potentially have. And I didn't even look to see like the histograms. What the heck is negative? So
Yeah,
this is probably the prediction.
Yeah.
So basically, really early on in learning, it maybe predicts negative because it's randomized weights, and then it quickly just says, no, never predict it. So it goes to 0.
You can do a lot of really interesting visualizations in Tensorboard that are nice and interactive. I have never really played with it, so I'm not sure. I've seen some crazy stuff where they're like visualizing the layers and stuff like that, but I haven't toyed with it very much.
Almost like capturing a sort of explainability at a certain level with the Tensorboard.
Yeah.
Yeah, so like a convolution, right? If you look at the activations, then it's sort of like a picture in and of itself, right? And so in this case, yeah, our precision recall curve is pretty atrocious. We're at 0.
This is steady.
We're consistent.
Yeah.
But so we can see these again next week, because next week we're actually going to fix some of these problems. And so it'll actually learn.
Mm-hmm. And you ran that against a subset of the data or the whole one?
I've only loaded so far 1/10 of the data on my laptop because I'm more interested in making sure that I understand the code. So I wanted the code to actually work. I'm not necessarily interested in trying to train it for accuracy, but I might. I can squeak by with actually loading all the data onto my hard drive. I'll just need to delete it as soon as I'm done, or I won't have any disk space left.
Yeah.
But I thought it was cool. So basically, you know, I'm an Anaconda, and I created a brand new environment for working with PyTorch. So I did not have Tensorboard on here. So I did install Tensorboard, and it warned me that not all the functionality is available because I don't have full TensorFlow installed, but whatever it did install seems sufficient, seems fine.
What were the requirements for you to load this into Tensorboard? Because I've only used Tensorboard with TensorFlow.
So basically the requirement, the requirement is that you have a runs, or is that you have a folder where you log information, okay? And each time you run your code, it's going to output this file here. This format needs to be the format that Tensorboard is expecting. Okay, so if you output this file in this format, then basically Tensorboard will know how to open it. Obviously, this is binary. It's gobbledygook to me, but it'll be able to read. And so in this case, you know, you have a bunch of stuff that you spit out every epoch, and so then Tensorboard will just happily suck this stuff in. And like Ryan said, I know you can do really fancy things with Tensorboard. One of the cool things about it is that while I was training, I had this web page, Tensorboard web page up, and it refreshed. So I didn't have to do anything. The graphs would just keep adding points to the right as each epoch finished. So somehow it has a watcher, and so it saw that the file was modified, the log file was modified, got appended, and then it's like, oh, okay, then let me grab those extra data points, add stuff to the right. So I don't know. I haven't used Tensorboard that much. I don't know if anybody here can share more. I'm not the expert on it.
I don't think there's really much in terms of requirements. I think that all you need to do is, like Ted was saying, you just have to have a folder, and then you use that utility from PyTorch, and it will just output whatever stuff you want sequentially and just basically write new lines to it. And then Tensorboard is able to load it in and understand the format of it and say, okay, this whole column of data goes together and this whole column of data goes together, and then it can just plot it. I don't think there's not too much fancy going on. I think if you look at the log files, it's probably pretty simple.
Yeah, and then within Tensorboard, there's different data types that they support. So in this case, just something like the loss, that's just a scalar number. So that's why it's showing up on this scalar screen. And so where things get really fancy is if you start spitting out more than just a simple number.
Cool, thank you.
Does anybody here use Tensorboard?
I used it for the hands-on machine learning book that we did last time.
Yeah, crickets.
I did a training with what's his name, Lucas, the guy from Weights and Biases, and so you know they have a Weights and Biases module, and so you basically it's pretty lightweight. You sort of import it at the beginning, and then when you have a metric, you just sort of put a wrapper around it so that it gets logged off. But then they have these nice, pretty curves and stuff too. I thought it's a similar thing, especially if you want to compare different runs and see how they look differently. And then I think one thing that they did that was a little bit nicer than just this vanilla Tensorboard, or maybe there's an option that I don't know about for Tensorboard, but you could say, I want you to sort my runs based on whatever. So like based on accuracy. So rather than just having this big mishmash of date time-stamped runs, it could say, yes, here was the run that finished with the highest accuracy and the second highest and the third highest.
Weights and Biases is a funny company. They had a hackathon that they held at Qualcomm, and it was supposed to be this thing where they were sort of teaching us about the tools, sort of teaching us about machine learning. And they held a sort of pseudo competition where they said, basically, here, run in our environment, and we'll have a really quick hackathon competing for this competition. And when we got there, they exposed to us that we were competing on the MNIST data set. And they gave us a predefined like starter code for us to run. And then because it's MNIST, people very quickly just got 100% accuracy on it. And that was the end of the competition. And it was very unsatisfying to me. But they
How long ago was this, Ryan?
Long ago. What?
How long ago was this?
Maybe a year ago. I don't remember the exact timing. But it was just a funny interaction. They had 300 plus people, and then they had us solve MNIST. For the people that were new to machine learning, it was probably interesting. For me, it was not super interesting. And the competition had like legitimate prizes worth like hundreds of dollars, and it was just a crapshoot because it was just who could find the magic seed to get 100% accuracy.
My guess is that they've come a little ways since then.
Yeah, their product at the time was already fairly developed, and it was interesting. Their product was nice. Everyone was working with it, and it worked well. But it was just very much a PR move to get people in there and then give them a very trivial task.
Yeah, I imagine that's sort of a trade-off in a community that's got lots of different levels, right? Like, if you're trying to plan an event, how much time do you put into trying to make it a challenging thing versus something that at least some people will finish?
Right. But I mean, they didn't have to go to like ImageNet. They could have just done like CIFAR or something that actually you won't get 100%.
Yeah. Maybe it was a busy time and they had to be lazy.
I can't remember the company that it was, but when I was at UCSD, they had some data science club there. It was like the first time I ever decided to go out to one of their meetings, and they had like a couple talks by some industry professionals, and there was supposed to be a hackathon after. I don't remember the company that was sponsoring it, but there were like 200-300 people, and we had the exact same situation where they literally just gave us the MNIST data set. But they took it a step further. They like passed around like 2 USBs to everyone to get the actual data. And then you open it up and you see, oh, this is literally just the MNIST data set. And like by the time the USBs are still going around, because they only had 2, like people have already finished the whole entire challenge. And they also had like pretty legitimate prizes. I just think they didn't know like what level of students would be coming, but half the people there were like basically doing their masters and stuff too. But yeah, it was supposed to be like I think like a 12-hour thing, and within like maybe 2 hours, people had like literally hit the 100%.
Yeah. We're over time at this point, so probably time to wrap it up. So next week, Ted, correct me if I'm wrong, but we're doing chapter 12.
Correct.
Yeah.
Yes.
So we'll read chapter 12, do more of the same, discuss it, go through the code, all of that stuff. And then after this, we'll take a short, I don't know how long break, and then we'll come back and we'll discuss whatever projects you guys are working on, if anyone wants to stick around for that.
Yeah, sounds good. So for the book club, we'll see you next week. And please do, I'm asking, please think about topics. So I've talked with Steven. I think he had to leave at 1, but he's going to do an overview of RapidMiner. And I've been thinking about, I don't know if there's any SQL topics that people would be interested in. I'd be happy to talk about SQL stuff and or look to see what other stuff is out there that's good. But if there's other topics, Ryan, I was looking at, you know how we talked about it at some point, but I don't think it was in the book club. You know how Jay Alamar has the like Transformers Illustrated, Bird Illustrated. Yeah. Those are like two really great articles.
I don't know how interested everyone is in getting too specific with stuff, but after I took that, the latest NLP course, it was essentially on transformers and attention, and I didn't really like the course that much because of the way they implemented stuff, but I spent like a lot of time over the past 2 weeks, like looking over everything myself and making my own notes. So if people are interested in how like attention and transformers work, I could put together a presentation on that and share a lot of those resources. I kind of went more at like a technical standpoint specifically of how they work, but we could always tie it in compared to RNNs and all that stuff. But yeah, I have a lot of recent notes on attention and stuff and going through those papers too.
Yeah, so I don't know, Ryan, we might even make more than one session out of it, you know, cover different angles. I'd be really interested to hear what you came up with, Vibhu, you know, and kind of summarizing what you think. I think there's a lot of, everybody knows right now that these large attention models are performing state of the art, right? I think there's a lot of interest now in how they work and why they work.
Yeah, that's pretty much what I spent the past 2 weeks going over, how they work, what actually goes on with attention. So I could put something up for that after we're done with the book.
Yeah, thanks. Yeah, so please, everyone, keep the juices flowing. I think what we're probably going to do is just some different community topics and take a little bit of a break before we start. We're not going to go immediately from last chapter of this book to, you know, chapter 1 of the next book. So feel free to post stuff in Slack, or you can, again, you can private message if you don't want to post publicly. If you're either volunteering to talk about something, or if you want to just ask and say, hey, it'd be great if we found someone who'd be willing to talk about X. All right. So see you guys next week. Ryan, you want to take a 10-minute break?
Sure. Yeah, sounds
and then
good to me.
20 after, we'll talk about projects. And then I haven't had a chance to look at it, but I was hoping maybe we could talk about the brand new read competition that they posted. Sure. And I haven't looked at it yet, but I'm thinking maybe it's going to be a really interesting one.
Yeah, we can discuss that one.
All right.